do we model data with quadratic functions? And we're going to be learning about quadratics today. We talked a little bit about this. We know that a quadratic has a squared. A quadratic, when we graph it, is a, what is it again? Parabola. Okay, so we know what a quadratic is. Go to the next page. A quadratic function is a function that can be written in standard form. Does anybody know what the standard form for a quadratic is? No? Okay, the form that I want you to remember, you're going to type this in or write it down. Y equals ax squared. Remember to put in your caret before you put in the x. That way it'll come out correctly. Plus bx plus c. Have you seen this before? What do a, b, and c represent? Numbers. Good. What's our variable here? X. Okay, good. So we know what a, b, and c are. We've all seen this form before. This is one of our normal quadratics. 9 times out of 10 when we see something like this, we factor. Okay, so all of these things are going to come into play. Next page. The next 2 pages are examples of parabolas or quadratics. Find and label the vertex, and you're going to tell me if it's a maximum or a minimum. And we're going to find the axis of symmetry. Okay, so go ahead to the next page. Here's our first example of a quadratic. So we have a couple of things that we can do here. Our calculator is very nice in that it will give us the equation of this line. But how do we get the equation of this line? What do we have to do? Okay, take your cursor, and you're going to touch that graph. Notice what comes up in the upper left-hand corner. Okay, so you touch the graph, the equation comes up, negative x squared. F of x equals negative x squared. Again, f of x is the same thing as y. Okay, so there's the equation, right? So I asked for a few things here. I want to know where the vertex is. I want to know whether the vertex is a maximum or minimum. And I want to know what the axis of symmetry is. Are we all familiar with those terms? No? Yes? Yes, okay. So, where's my vertex? Huh? At the height of it. And who just said the word? Origin. The vertex is at the origin. Very good. What is the origin? What's the point? 0, 0. Okay, so who can tell me how to put text into this? Right into this. Control T is going to give me a table. Where do you think you should go? Go to menu. Actions. Text. Good. So what you're going to do is you're going to bring it over here, and I want you to write in vertex. And you're going to tell me if it's a maximum or a minimum. What do you think? It is a maximum. Very good. Vertex is a maximum. Ooh, I got double V's and double R's in there. Okay, so the vertex is a maximum. Now what I want you to do is I want you to put a point on that vertex. So how am I going to find my point tool? Okay. Points and lines. And then number 1, which is point. You just go ahead and put a point on that vertex. Okay, so we know what that vertex is. Okay. Okay, somebody tell me what axis of symmetry is.
Is that when it cuts in half?
Yeah, where it cuts it in half. So where could I draw a line that would cut this quadratic in half, parabola in half?
You're asking what is that?
No, where could I draw the line? write down the y-axis, right? Here is my axis of symmetry. My axis of symmetry is a line that I would put in that I could take this parabola and fold it in half. It would match on either side, right? When we draw axis of symmetry, the line, it's always dotted. It's not solid, okay? So what I'm going to have you do now is, again, use your text tool. So go turn on your text tool. And I want you to write me the equation of the axis of symmetry. You're going to put in axis of symmetry. And you can shorthand it. I'm going to put axis of sim. And I want the equation. So who can tell me the equation for the axis of symmetry? Very good. X equals 0. Perfect. Okay, so the equation for the axis of symmetry is x equals 0. Now, axis of symmetry, always x equals 0, unless our parabola is lying sideways. Okay, then it's going to be a y equal. But for parabolas that are up and down, that's always x equals. Okay? Any questions? No? Okay. So on the next page, what I want you to do is I want you to put a point on the vertex, label it a maximum or minimum, and then give me the equation, the equation for the axis of symmetry. Okay? Okay, so where's the vertex? At the origin again. There's your vertex. And is it a maximum or a minimum? Minimum. And the rule is if the quadratic can hold water, it's a minimum. If it can't, it's a maximum. Okay? All right, axis of symmetry, what is it? What's the equation? X equals 0 again. Good. Any problems? We okay with this stuff? You learned this in integrated algebra, and then you learned it again in geometry. So this should be pretty solid for you guys. Okay. All right, so next page, please. All right, in your own words, I want you to describe what the axis of symmetry and the vertex are. So take a minute in your own words to describe what those two things are. Okay. Dan, tell me what a vertex is. What'd you put?
A vertex is like where is in between the two halves of it.
Good. It's the place where it sits right in between the two halves. Good. Okay, so let's have Fran. Tell me what axis of symmetry means to you.
The line that separates the parabola into two identical halves.
Beautiful. Good. Okay, can you tell me how the vertex and the axis of symmetry are related? What do those two have in common? What is always going to happen? The vertex is always on the axis of symmetry. Good. So if my vertex was the point 3, 2, my axis of symmetry is x equals 3. The x values are always the same. Okay? So that's something important that you should know. So why don't you make a note of that, okay? The vertex will always lie on the axis of symmetry. So the vertex, the x value, is your axis of symmetry. Okay?
What's that again?
I don't know what I just said. The vertex point will always lie on the axis of symmetry. So the x value for the vertex is your value for your axis of symmetry. Okay? All right, so what happens when I have a vertex or an axis of symmetry that doesn't lie right on a nice integer value for us? It's not a 1 or a 2 or a 0 or a 4. We get these crazy parabolas that don't line up nicely for us. Okay? When we get something like that, we have a formula that we use to find the axis of symmetry. All right? So, you're going to put in the formula. You ready? Write down axis of symmetry, shorthanded if you'd like. Axis of symmetry. The formula for this put in a fraction template. Negative b over 2a, and that equals x. Okay, so to find your axis of symmetry, you use negative b over 2a. That's the formula we would use. Where would we find the a and the b?
The quadratic equation.
From the quadratic equation. Good. So let's say, we'll do this right now. Let's say I have the equation 2x squared minus 3x plus 4. There's my quadratic, equals y. Okay? I wanted to find its axis of symmetry. How am I going to determine A, B, well, A and B? What's A going to be?
2,
What's B?
3.
Okay, so put in a fraction template. We have negative, and then you told me B was negative 3. So negative 3 over 2 times, what's A? 2. Okay, so what is my axis of symmetry? What is it? 3 over 4. That equals x. Okay? So my axis of symmetry is the vertical line, x equals 3/4. Okay? So I've got my axis of symmetry. Could I go find my vertex point? I know my x value. I know that my x value is 3/4. Could I find my y value? If I know my x value? How?
So x is 2x.
Very good. You'd sub in 3/4 into the equation. Now, do you want to work fractions? Do you? What does our calculator do for us? That all of you should have done on the test and a lot of you didn't. Okay, so by using the store key, we saved 3/4 as our x value. We put in our 2x squared minus 3x plus 4, and we got 23 over 8. Now, would you have wanted to do that by hand? No, probably not, but could you have? Sure. Okay? So get used to using that store key. We are going to use it over and over and over again. You have to get used to it. All right, so what does this point now represent? You've got your x value, matches up with your axis of symmetry. You've got your y value. Say it again, Kirsten. Vertex. So that is the vertex. Okay? So if you're given the axis of symmetry, you can use it to find the vertex. Okay? How are we doing? Have you seen this before? Kirsten has. I have my kids out here in 9th grade in Frankfurt. Done. Okay, next page. We're going to talk about a real-world application. Okay? Real-world application, hydraulics. The data below shows the height of a column of water as it drains from its container. Model the data with a quadratic function. Graph the data and the function. Use the model to estimate the water level at 35 seconds. And then we're given a big chart of data, right? What do you think I'm going to do with that big chart of data? How am I going to graph it? What do I need to enter it into first? Table. So what am I going to add in? Control I. And you're going to put in a list and spreadsheet. Very good. So take a minute to put that data into list and spreadsheet. Now remember, A and B in that list and spreadsheets. No capital letters, no spaces. Okay? So enter your data into the list and spreadsheet, please. Okay. Now notice after my last piece of data I hit enter, correct? If you leave it in this box without hitting enter, your calculator will read it as a mismatch. It doesn't read all the data until you hit enter and it solidifies that data into the spreadsheet. Okay? So make sure that after your last piece you're hitting enter so that you're out of the boxes with the numbers. Okay, and after I enter a list in spreadsheet, what do you think I'm going to add now? Data and statistics, so Control I. You're going to add data and statistics, which is going to give us our scatter plot. Remember doing this when we were doing regression lines for linear regression? Okay, well what we're doing now is we're doing quadratic regression. Same exact thing, except we're dealing with different values. Okay? So add your variables. Along your x-axis is going to be your A or B. A, so that's going to be time. Along your y-axis, you're dealing with level. And it's going to give us a nice pretty picture that looks like this, right? Is it linear? No. This is a nice curve to it. So what we're looking at is we're looking at a quadratic model. So who can tell me how to find the quadratic representation, an equation that would fit this quadratic data? Where would I go? Think back to when we were doing linear regression. This is quadratic, same thing, except we're not doing linear, so where are we going to go? Menu, analyze, good. Regression, and you're going to choose show quadratic. Remember? So here is our regression line. Remember, you may not be able to see all of it, so you may have to move it. Okay? We get this nice long equation. Does everybody have the equation? Okay, so this is your regression equation. All right? So now we're going to use this equation to solve the problems that they were asking of us. So go back. Okay, let's look at what they want us to answer. Use the model. That is the model. The quadratic regression is the model. Okay? Use the model to estimate the water level at 35 seconds. 35 seconds. What value is that? My x or my y? X. So, how can I make sure that I get this correct? Store it. At a calculator page, store x as 35, and then put in the formula to get your value for y. Okay, so do that now. What'd you get? I can't see mine. Okay, so to the nearest, what of our millimeter? Nearest millimeter, it's going to be what? 58 millimeters. Easy? Any problems? No? Okay. So I want you to move ahead, and I want you to do A, B, and C. Okay, so take a minute, do parts A, B, and C. Mooch, if you want to move up and work with Josh, you can do that. Okay, so when you did it for 25 seconds to the nearest millimeter, what did you get? 73 millimeters. Does everybody agree with that? Yes, no? Yes, okay. Use the quadratic model to predict the water level at 3 minutes. How'd you get it?
Because the mass is 80.
Okay, good. So, this is wanting it at 3 minutes. We said time was in terms of seconds. So can you put in 3? No, you have to change 3 minutes to 180 seconds. And then when you put it in, Edith, what'd you get?
John, just give me the S.
Yes, 39 millimeters. Are we okay with that? Okay, the last part of this asked, is your prediction in part B reasonable? 39 millimeters is reasonable. Now, had you put in a 3, would it have been reasonable? No. So that question was there to check yourself to make sure that you change those units. Okay? Doing all right? Excellent. You guys are making me happy today. Okay, so now what I'd like you each to do is one person from each group is going to get up and get one textbook. So one textbook per pair. Okay? Your homework for tonight is lesson 15 on your handheld. The first few questions, they're asking you to take 3 points and get a regression or a quadratic model. What you're going to do is you're going to put those 3 points into a list and spreadsheet and then create a scatter plot and find the quadratic regression.